Welcome to lesson 3.6. In this lesson, now that we've talked about inverse functions, or I should say derivatives of inverse functions, we're going to specifically talk about derivatives of inverse trig functions. But before we do all of that, let's do a really in-depth review of inverse trig functions, since it's probably been a while since you did it, if you did it at all. So just so you know, example 1 through 8, all the way up through example 8, this is all review of inverse trig functions. It's nothing new, actually. We don't get to the new stuff until example 9 down here. So the first few videos for this lesson are all just going to be, let's review some inverse trig stuff and some basic trig stuff too. So, something that we need to start with. None of the 6 basic trig functions is one-to-one. Just a reminder of what one-to-one means. One-to-one means it passes the vertical line test and the horizontal line test, both of them. So if we think of like the sine of x function, which looks like that, this one passes it passes the vertical line test, meaning I can draw vertical lines whenever I want and it only crosses the graph once. However, it does not pass the horizontal line test. Any horizontal line I draw is going to cross the graph more than once. The reason both of these tests are important: vertical line test says it is a function. If it passes the vertical line test, it is a function. So sine of x is a function because it passes the vertical line test. The horizontal line test says if the inverse is a function. So this one does not pass the horizontal line test, so the inverse is not a function, which is a problem. We like things to be functions, because if they're functions, they follow certain rules and then we can do stuff with them. So generally what we do in that instance is we do what's called a domain restriction. We restrict the domain to only a certain section so that then it actually is one-to-one. A good example of this is our parabola. If you look at a parabola, this parabola passes the vertical line test, so it's a function, does not pass the horizontal line test, so the inverse is not a function. But if I restrict the domain to only this piece, so I've restricted the domain to only x greater than 0, now it passes the vertical line test and the horizontal line test. That's why the graph of square root of x is only one side of your parabola, because they made that domain restriction so that the inverse is also a function. That's that whole point. So right here, definition of inverse trig functions, your inverse trig functions all have domain restrictions so that the inverse is a function. So let's go through and graph these trig functions so we can see what the domain restriction looks like and what the graph of these inverse trig functions looks like. To do that, what I'm going to have you do is fill in these tables. Do these first. So I want your x values to be this. And then, let's see, this one. You'll notice as I'm writing these x values that they all go between the domain restrictions listed above. So sine is between negative pi halves to pi halves. Cosine is 0 to pi. Tangent is negative pi halves to pi halves. Okay, so I want you to pause the video, take a second with your calculator to plug all these values in. Make sure your calculator is in radians, not degrees. So plug these values in and fill in the table. When you're done with that, come back and we'll graph them from there. Welcome back. Now you'll notice I specifically used the decimal approximations of these points, not the roots, because I'm going to be graphing them and it's easier to graph 0.707 instead of root 2. Now, let's look at this. When I'm graphing the inverse, remember I flip the x's and the y's. So that's what I'm going to do. Instead of graphing negative pi halves comma negative 1, I'm going to graph negative 1 comma negative pi halves. And then same thing here. Instead of graphing negative pi fourths, negative 0.707, I'm going to flip it. Negative 0.707, which is there-ish. Negative pi fourths, which is there-ish. And then 0, 0 flipped is still 0, 0. Flip the other one, 0.707, comma pi fourths. And then 1, comma pi halves. So this shows you the graph of inverse sine. And note that these are points, not arrows. They are not arrows because of this domain restriction, and notice that my domain restriction is brackets. So it's going to be bracket closed points from there to there. That's my inverse sine function. Now I want you to do the same thing for the next two. Pause the video, graph them, and then see how they turn out. And for your tangent, remember that undefined is an asymptote. Welcome back. You should have gotten this for the graph of cosine, and then this for the graph of, inverse cosine, I should say, and then this for the graph of inverse tangent. Notice that this fits why they have parentheses on the domain restrictions instead of brackets, because there are asymptotes, so we're never going to reach it, so that's why it's a parentheses, not a bracket. So that is the graph of each of these inverse functions. In the next video, we're going to review how to apply these inverse functions.